Magandang buhay, my grade 8 learners. This is Sir JOEV, and welcome to our video lesson for lesson content of your self-learning module number 1. This learning material that I created will help you understand the concepts of Newton's first and second laws of motion. Are you ready? Let's go! When we talk about Newton's first law of motion, inertia must be understood and remembered. Inertia is the natural tendency of an object to resist a change in their state of motion. In simple words, it is a property of an object like object's mass, color, length, and the like. Inertia of an object makes it stay on its states of motion. Ibig sabihin, kapag ang bagay ay nakahinto, mananatiling nakahinto ito dahil sa kanyang inertia. Gayon din kapag ito naman ay gumagalaw, mananatili ito sa kanyang paggalaw dahil sa kanyang inertia. What does inertia do to an object? A still object will stay not moving because of its inertia. Halimbawa, ang isang bola sa lupa na hindi gumagalaw ay mananatiling nakahinto dahil sa taglay nitong inertia. Ang mga bagay na hindi gumagalaw ay hindi gagalaw dahil sa inersyang taglay ng mga ito. A moving object will stay moving because of its inertia. Halimbawa, ang mga bagay na gumagalaw ay mananatiling gumagalaw dahil sa kanilang inertia. Isang magandang halimbawa nito ay ang pag-ikot ng mga kometa o comets sa ating solar system. Nananatili silang gumagalaw paikot sa ating araw nang walang hinto. Ang inertia ng isang bagay ay kaugnay ng kanyang mass. An object with more mass has more inertia. An object with less mass has less inertia. Ang isang mabigat na bagay na nakahinto ay mahirap pagalawin dahil mataas ang taglay nitong inertia. Gayon din naman ang mga magagaan na bagay na nakahinto ay madali naman pagalawin dahil mas mababa ang taglay nitong inertia. Ang isang magaang na bagay naman na gumagalaw ay madaling mapahinto dahil sa mas mababa nitong inertia na madaling nagpapabago ng kanyang kondisyon. Less inertia, ang ibig sabihin, ay mabilis na mababago ang kondisyon ng kanyang paggalaw sa pagkahinto nito. Kung ang mga kometa sa kalawakan ay gumagalaw ng walang hintuan, bakit po ang sinipang bola na gumugulong sa lupa ay humihinto pagkalipas ng ilang sandali? Hindi po ba dapat na manatili ito sa paggulong dahil sa kanyang inertia? Ang sagot ay oo. Dapat ang bola ay mananatiling gumugulong ng walang hinto, ngunit hindi ito nangyayari sapagkat may nakakaapekto sa bola kaya ito humihinto sa ilang sandali. Ito ang paliwanag ni Sir Isaac Newton sa isa sa kanyang mga laws of motion. Law of inertia states that an object at rest will stay at rest and an object in motion will continue its motion unless acted by an unbalanced force. Kagaya ng nabanggit kanina, ang mga bagay na nakahinto ay hindi gagalaw at ang mga bagay naman na gumagalaw ay mananatiling gumagalaw. Ngunit, kagaya ng sinipang bola sa lupa, ang gumagalaw na bola ay hihinto sa ilang sandali sapagkat may nakakaapekto dito upang magbago ang kanyang paggalaw. Ito yung tinutukoy sa ikatlong linya. Mayroong unbalanced external force na nagpapahinto sa galaw ng bola. A rolling soccer ball will eventually stop. What makes the soccer ball stop? It is the force. Force cannot be seen by our eyes. We can only see its effect to the object through its motion. A representation using arrows will help us visualize the forces involved. The friction force between the soccer ball and the ground makes the ball stop. Aside from the applied force given to the soccer ball after kicking it, there are other forces acting on the ball. The gravitational force, force of attraction between the ball and the earth, and normal force, the force exerted by the ground to the ball. Where can we apply Newton's first law of motion? You must fasten your seatbelt to avoid major injuries when collision of cars happens. What is the science behind it? During collision, the moving car will abruptly stop when hitting the other car. In this case, your body will continue to move forward because of your body's inertia. The seatbelt will prevent your body to be thrown forward and hit the windshield of your car because of the external force that the seatbelt will provide for you. Amazing, isn't it? So, seatbelts, helmets, airbags, and car headrests are important and can save lives during an accident. Another law of motion which Sir Isaac Newton proposed, which is the second law of motion or the law of acceleration, which states that acceleration of the object is directly proportional to the force applied on it and inversely proportional to its mass. The direct proportionality of force to the acceleration and the inverse proportionality of acceleration to mass are being illustrated in tables 1 and 2. The direct proportionality of force to the acceleration of the object when mass is constant while the amount of force is increasing shows the calculated acceleration in table 1. To compute the acceleration, force is divided by the value of mass. For trial 1, 10 newtons divided by 2 kilograms is equal to 5 meter per second squared. The unit acceleration is derived when newton is expanded as kilogram multiplied by meter per second squared. Then, kilogram unit will be cancelled out, retaining meter per second squared unit. For trial 2, 20 newtons divided by 2 kilograms is equal to 10 meter per second squared. Then trial 3, 30 newtons divided by 2 kilograms is equal to 15 meters per second squared, giving us a conclusion that the more force you give to an object, the more the object accelerates. As shown in table 2, when force remains constant while changing the object's mass, object's acceleration changes as well. To calculate the acceleration in trial 1, 20 newtons divided by 2 kilograms is equal to 10 meter per second squared. Trial 2, 20 newtons divided by 4 kilograms is equal to 5 meter per second squared. Trial 3, 20 newtons divided by 6 kilograms is equal to 3.33 meter per second squared, giving us an idea that the more mass of the object has, the lesser its acceleration. Tables 1 and 2 shows the direct proportionality and inverse proportionality of acceleration to force and mass. Force is directly proportional to acceleration, meaning more force you give to an object, the more the object accelerates. And the lesser the force you give to an object, the lesser its acceleration, as represented in table 1. Moreover, mass is inversely proportional to acceleration, meaning the more massive the object is, the lesser the object accelerates. And less massive object is, the more the object accelerates, as shown in table 2. Just like a fully loaded school bus as compared to an empty school bus, a fully loaded bus accelerates less as compared to an empty school bus running with the same amount of force given by the engine. There are lots of examples that we can observe the application of Newton's first and second laws of motion. Thank you for listening. I hope you learned a lot from this video lesson. See you again next time. Bye-bye.